Digitalization and Industry 4.0 SME, for being here to share his knowledge and experience in the area of IoT and blockchain technology. On this great day with merging of minds, we welcome you, sir. I would like to welcome our SB counselors and the society advisors of JIT IEEE SB and IEEE BUBTSB. It is my turn to extend a gracious and inclusive welcome to all the volunteers and the participants. I'm very happy and grateful that so many distinguished scholars, faculty members, and students have come from various regions to have active and interactive learning on IoT and blockchain. I welcome you all with immense pleasure. Thank you.
Thank you, Sophia. Now I would like to welcome Dr. S. Ilagovan to provide the opening remarks.
Thank you, Mr. Heram. I'm indeed pleasure in having this webinar as a celebration of IEEE PES Day. So IEEE PES is nothing but a very old society. It is a power and energy society. So this particular society is on behalf of this society is giving complete information about the power delivery, power generation, sustainable power, smart grid. So you will have a lot of transactions in IEEE Power and Energy Society. And this is one of the very older society of IEEE headquarters. And as far as the IEEE Power and Energy Society is concerned, IEEE Power and Energy Society has given free membership for the students for the first year. So it is attracting the student members a lot, and of late, the last 5-6 years, IEEE Power and Energy Society is going a big way. As far as the IEEE Madras section, so our SB, JIT SB is coming under IEEE Madras section. IEEE Madras section is really doing very great activities all these days. And as far as Madras section is concerned, they have this year they have started a flagship conference like Indicon. We'll have IEEE Indicon conference, a flagship conference of India Council. Likewise, we'll have R10 conferences, 10Con. So like that, MassCon, it has been initiated this year, and they are started giving a lot of funding and other things. So I would like to thank the Bangladesh University for collaborating with us. So I would like to thank the Madam IEEE Bangladesh section chairman, Celia Shahnaz. So we have collaborated with her in a few activities. She had invited me for 2-3 activities, and we have invited her. So I think it's a good rapport created between the JIT and IEEE Bangladesh section. So thanks to Fahima, Sophia Fahima. She's a coordinator from JIT side. And I would like to thank the authorities of Bangladesh University student branch. So I hope this particular webinar will be an eye-opener on IoT in power and energy society, right? So I would like to thank Dr. Somasundaram sir, being a friend for me for a long time. So technically, he has given a lot of inputs to me, and he had helped me a lot in organizing the webinars, or he had delivered a lot of webinars, and he has been one of our native speaker, I will say, as far as JIT is concerned. So thank you for accepting our invitation, sir. I hope the whole bunch of students and professionals who have joined for this webinar will take a lot of takeaways from this webinar. I hope that will happen with the enlightened address of Dr. Somasundaram. Thank you one and all.
Thank you, sir. Now I would like to call upon Traikul Islam Roman from BUPTSD to present the speaker profile. Raymond?
Assalamualaikum to everyone and a very good afternoon to all. Welcome to today's seminar on applications on IoT and blockchain technology for future smart power system, organized by Janssen's Institute of Technology, IEEE Student Branch, Madras Section, and IEEE BUBT Student Branch, Bangladesh Section. Ladies and gentlemen, this is your host, Tariqul Islam Rimon, Department of Tripoli, and the Membership Development Coordinator of IEEE BUBT Student Branch. Today, our speaker is Dr. Shoma Sundaram and Bala Subramaniam. He is a business development of professional educator, researcher with proven and awarded Industry 4.0. Digitalization, Six Sigma, Lean Manufacturing, Energy Management System, implementation experience in leading MNCs like Saint Gobain Glass, Velo Hansen Drives, ZF, and Siemens. He is a continuous learner and proud alumnus of IIM, Liverpool John Moores University, IIT, Bangalore, CEG and University and GPT. Thank you.
Thank you, Raymond. Now I would like to welcome Dr. Somasundram Balasubramanian sir to present the presentation. Welcome, sir.
Yeah, thank you, everyone. Thanks for the warm greetings. Yeah, let's go to the session. And before going to the session, I like to make some ground rules. Okay, so I'm not going to use any PowerPoint presentations or anything. I'm going to interact with you, but in a more, I would say, in a informal or a virtual way. Yeah. So that's my idea of this, the way how I want to take this session forward. Yeah. So I'm going to use a platform called Mentimeter for this. Okay, and I hope many of you might know about this. That is what we are going to do now, and request you all to ping my screen. Okay, because I have logged in from 2 devices. So you have to ping my screen. Hope my screen is visible for you all. Okay, so
Yes, sir, it's visible.
Great. So you'll be hearing from one of my account, and you will be seeing something in another account. Yeah, cool. So first of all, I want to understand from you. Okay, so let's have some small things. Yeah, first thing what I want to understand from you is what is the device you are using for this session? Yeah, whether it is a mobile phone, laptop, desktop, or tablet. I think many of you might have used Mentimeter. It's very simple. Go use your mobile phone or your browsers. Go to www.menti.com. You can use the code 86061205 and cast your votes, please. Maybe for the benefit of some, I'm also putting the link in the chat so that what is my chat? Yeah, so that you can also click and cast your votes. And the results are here. I can see one person using laptop and desktop. So we are 89. Let's see how participative you all are. Okay, good. 4. Let's touch at least 50. So mobile is picking up. Yeah, no, laptop have taken over. Laptop have taken over. Laptop is leading. Mobile is lagging back. Laptop is leading again. Yeah, very nice. But I have only 17 votes. Yeah, it's 18 now. We are 92 in the chat. -2 of my ID, then it is 90. Minus organizers, it can be 80. So by this time, I should have got at least 50 inputs. Yeah, I have only 20 here. Request everyone to participate, please. '21. Oh, mobile is growing. 22. '24. Again, mobile is slowly progressing. I don't know. 25. Yo, great. Laptop is now increasing. 26. Okay, so first of all, there are 90 participants. Only I have 30 votes, approximately. I need more participation, please. More participation, please. Yeah. Someone have raised the hand, please. Any problem? I have 31 votes only now. Let's touch at least 50. Okay, cool. So I can see there is an equal divide between laptop and mobile. Okay, it's okay. So now I understand, like, now I understand. Yeah, it's not a link. You have to use the code. And I think I have already posted the link. Yeah, it's cool. Fine. So there are only 32 votes. I request all other participants also to kindly participate. Okay, unless otherwise you don't participate, this is not going to be a session of I don't know, use for you. Yeah, good. So there is an equal divide, and I can see most of you are using laptop, or most of the active people are using laptop. It's good. It's good. Great. So with this, let's go to the next important topic. Okay, what do you think about say? You think like, okay, smart power system is going is needed. Okay, that is what the purpose of this particular meeting, right? So let's understand from you what should be the priority of a smart power system. Yeah. So this is a different type of question. I hope it's a word cloud, yeah, something like that. Okay. So again, you have another mentee here. I'm just copying and pasting the link in the chat so that you can put your thoughts on this. Yeah. So what should be the priority of a smart power system? You can also give multiple entries. So no problem. Don't restrict yourself. There may be 2, 3 more priorities. But there is a limitation of words. So you have to put it concisely. Okay. Try to define it with 1 or 2 words. Yeah. 1 or 2 words. According to you, what do you think should be the priority of a smart power system? You have to go to www.menti.com, use the code 79260384. Okay, reduced emission, energy optimization, low cost implementation, less transmission loss, Less maintenance, very good. Yeah. What is this, 25? Okay. Any other useful information, please? Yeah. Management, protection. Okay, good. Yeah. Better energy management, grid systems. You don't understand what is grid systems you want to mean. Okay, so less maintenance. Yeah. Protection, automation, sustainable and secure. Okay. Power saving, better surveillance. Yeah. Less weight. Okay. Okay. So smart power system, less weight you want. Okay. Remote control. Okay. Automation. A lot of people, I think, they have put automation. Low cost. Smart grid. Okay. Smart power system is a grid. Yeah. Okay. Smart power system in a grid. Okay. It has to be a, it has to constitute to a smart grid. Okay. Information protection, control flow of power, reduced emission, smart energy, less weight. Again, here I have only 20, 21, 23. It is not matching to how many people we are. I don't understand what is Australia. Taken anywhere, okay. Implement batteries, okay. Information protection, okay. Okay. Something on sustainability, yeah, there is something like sustainable and secure. Reduce commercial losses, yeah, good one, catchy. Okay, good. So, yeah, so I think more or less, either if you know or don't know, okay, I think most of the answers are matching to the definition of what should be a smart power system, right? So one, it should be, obviously, availability is the first and foremost thing, yeah. After that, you have the other things of efficiency, that means less loss and other things, yeah. And after that, you have this. Okay, so hope my screen is visible for you all. And
Yes, sir, it's visible.
yeah, it's visible. So I'm now switching over to my another device. Yeah. Okay, great. So it's my iPad. That's for just for my convenience of writing. Okay. So you have mentioned like it is a smart power system. So the first priority is availability. Okay. Then it should be efficient. Yeah. And obviously it should be manageable. That is ease of maintenance. Okay. And there is something called resilience. Okay. That is, it has to be, say, available. Okay. Even when it is, what to say, disturbed, yeah, by, say, faults, environment, yeah, plus others. Yeah. So this should be our priority, right? So smart power system, first it has to be available, efficient, and it has to be manageable, right? Manageable, or I would say operatable. Yeah. Please ignore if there are some spelling mistakes, but I'm just on a higher level wants to give you a hint like, okay, these are all the requirements of a smart power system. Yeah. The very important aspect is, yes, these are all are possible, okay, and there are multiple things when we are talking about availability. Yeah. Nowadays, there is a growing threat of a power systems, especially with the cyber attacks. Yeah. So we have to have a secure infrastructure so that we avoid these kind of cyber attacks. That's very important. And another aspect, what is also coming up is saying it has to be uh, withstand the challenges, right? There will be falls, there will be some environmental conditions, and during that time also the system have to withstand. Okay, so it is the reliability of the system that's very important. So that is something is, I would say, the first priority for us. And after that, the second priority is efficiency. And the third priority is the ease at which we can operate it, and we can identify abnormalities in the power system much in advance. Okay, so these are all the things. Now, there are some new challenges which is also coming up. Okay, so the challenges like, okay, say increased use of EV. Okay, so EV is going to come up in future. Okay, these are all the challenges which is going to come in future. One is the electric vehicles. Okay, electric vehicles and the charging systems for it. Yeah. And there are some new things which is coming up, like I say, distributed generation. So it's not always like people distribute, or I would say generate at one single place. Nowadays, people are having even a solar rooftop. Okay, solar rooftop. Right? So that means I can generate for my home, and I can also surplus energy, I can kick it out. Okay? So these are all the other things which is coming up, and especially I strongly believe that this is the important challenge we have to immediately attend, so that we have a sustainable energy system. Yeah, energy system and our power systems are capable of having this particular sustainable thing, that is taking the solar energy and other things into it, and at the same time there should not be any problem with that. Yeah. So these are all the very important priorities of what we are thinking of. Okay, for the power system. Now, the topic is not about power system. What we want to think is how IoT and blockchain can be used in power systems, right? So that is the very important topic of this particular thing. Yeah. So now you have now told like what is the priority of a smart system, a smart power system. Now there are two topics in this particular webinar title. One is IoT, another is blockchain. So let's go to blockchain. Yeah, let's go to blockchain, or I would say, or we can go to IoT also. Not a problem. Yeah, IoT also. Let's have one more short Menti for this. Okay, what do you think about IoT application in smart power systems? Okay, what do you think? Yeah, that's all. So that you know, it is a 1 hour session. So we do I would say, yeah. Cross pollination, something like you understand from your peers. There are 90 people here. Okay, so I think collectively we are smart, or we are more intelligent than being one single person. That's the reason we use these kind of things. And this is going to be an open-ended question, I hope. Okay, so you can give your comments. Okay, according to you, what do you think IoT or where IoT can be applied? Okay, where or rephrase this. Okay, where we can apply IoT in a smart system. Okay. Apply IoT in smart system. Okay. Great. So this is our another Menti. Okay. So you have in your screen. Okay, and the code is also available 32209-538. If you want the link, I can also give you the link. Or I think this is better. You go to www.menti.com, use the code 32209-539. And please cast your votes. What we want here is where we can apply IoT in smart power system. So you know what is the priority of a smart power system. I don't want to go into the basics of what is a smart power system. Okay. Yeah. Now, yeah, great. So where we can apply IoT. Yeah. Smart meters. Okay. Great. And there are some interesting application what you have put like demand side management. Okay. In one of the things. Yeah. In home automation. Okay. Yeah. Okay, I have only 2 responses. In inverter technology, okay. Measuring usage, energy meters, home automation, okay. Remote monitoring and automation, yeah. Production, okay. Smart meters, electrical vehicle, agriculture, okay. Traffic management. But I want you to go into little details. For example, remote monitoring and automation, it's good, yeah. In manufacturing, where? Okay. Something like that. You have to go a little deep inside. Now we know broader where it is, right? So now we have to go a little deeper. Where to use it, in which use case to use it. Yeah. Distributed line for locator, okay. Automated power generation and usage in today's scenario at hospital. Power restructuring, smart waste management, control smart devices, you don't know. Energy supply, hospitals, yeah. Medicine. Okay. Sensor and monitoring. Anything more? Yeah. I don't know, something. Various manufacturing systems. In the essential part for collect and optimize data and use of the intense analytics in order to know where we should focus in distributed system. Very good. Smart infrastructure, load management. Okay. Any other use case? Okay, microgrid, water distribution, okay. Smart parking. Okay, good. So there are some good information you guys have given. Okay, so let's go to some of the use case or the use case where I have used personally a smart power system in one of the plants. Okay, I will just explain to you how we used and what is the use case. Yeah. So again, I'm going to my notes. Okay, so this is with one of my example almost I think 7-8 years back. Okay, yeah, 7 to 8 years back. But I feel this particular use case is more applicable even today. Okay, and we can learn a lot from this. Okay, so I was the say the facility manager of a big company. Okay, manager. Okay, and the problem is a problem for this facility manager. Okay, so unfortunately it is me there. Okay. So suddenly what happened is there is a, I was working for a company which was manufacturing a wind turbine gearbox. Wind turbine gearbox. Okay. So wind turbine gearbox, how normally it is manufactured is there are, I would say, 2 important components here. One is the casting, which is the outer body of a gearbox, and you will have a lot of gears. Okay, this is the, I would say, everything, okay, or working elements, elements or gears. Okay. Okay. So casting is a no problem for me, but this particular gears is a problem for me because gear has lot of process. One of the process is heat treatment. Okay. Heat treatment. In this heat treatment, there are two things. One is called carburizing. Okay. It's one of the mechanical heat treatment or a metallurgical one, and another is called nitriding. Okay. And this is very, very important, or I would say key factor for the reliability of the gearbox. Okay. Reliability of gearbox. Okay. And there is something called, I don't know how many of you have heard about this. There is something called VUCA. Okay. V is called volatile, okay, uncertain, and C is for complex, okay, and A is ambiguous. Okay, normally, say last decade or so, or even now, things are very volatile, right? So we don't know when the virus is going to come or not come. Okay, so a lot of things are there. Okay, and everything is uncertain. Okay, volatile, uncertain, and it's complex in nature. Okay, environment is complex. It's ambiguous. It's doubtful always. Okay, so this is the reality of our real world. Okay, so the same way, the company where I was working, they were also having a VUCA situation. Okay, and suddenly they told like we are going to have some more furnaces. Okay, they want to add furnaces, add furnace. Okay, and this furnace is an electrical furnace. It is an electrical furnace. Okay. So now, what is an electrical furnace in an electrical point of view? Okay. So first you will have a power supply. Okay, and this power supply here in this case is 415 volt. Okay, AC. And if I draw the single line diagram, so you will have an isolator. After that, you will have some contactors. Yeah. Okay, and then you will have say a thyristor, okay, or I would say a series of thyristors, okay, thyristors. I don't know. Okay. Okay, and this gets connected. Yeah. So this is the thyristor symbol. Please ignore if I am not neat in my things. Yeah. So there are thyristors all over. This is T1, and I have one more thyristor here. Okay. Thyristors here. Okay. This is T2, and I have one more. This is T3. Okay. Yeah. And this thyristor has I would say a signal. Okay, so this is the power, right? Okay, so I have air control signals also. So what happens is there will be one more grid which also will travel like this. Okay. Yeah. And this gets connected to something called programmable logic controllers, PLC. Okay, so this PLC has an input from a thermocouple. Okay, so it will have a thermocouple. Okay, and you will have for each region. Okay, there will be T1 thermocouple, T2 thermocouple, and T3 thermocouple. Okay, for each and every zone there will be a thermocouple. Okay, so these are all called zones actually. Okay, T1 is for say top zone, middle, and bottom zone. Okay, now from here the output is going to nothing but a resistor. Okay, everywhere. Oh, it is not resistor, it is inductor what I am drawing, right? Yeah, so it is resistor. Okay, and I have resistors here. Okay, and these resistors are, I would say, all connected to a neutral, and it is going back. Okay, I'm not going into that now. Okay, so these are all the resistors. So I will name this as R1, okay, R2, R3. Now what happened? This is one furnace. This is what one furnace means. Okay, one furnace. This is completely one furnace. Okay. Similarly, I have say almost 13 furnaces in that plant. Okay, 13 furnaces of such. 13 furnaces. Okay. So in this 13, there were some 8 furnaces already running, and suddenly the management have told like we are giving you 5 more furnaces and you have to add it. Okay. So now, what would be the challenge? Okay, can someone unmute and tell what would be the challenge if suddenly people are asking to add 5 furnaces? Okay, business requirement is add 5 furnaces. Okay, can you unmute and speak, please? What do you think would be the problem if suddenly they are asking you? You are the electrical manager. Okay. Yeah. And each furnace is of 600 kilowatt. Okay. Yeah. Suddenly they are asking you to add 5 more furnace. What would be the challenge? Can someone unmute and speak, please?
Maybe the current rating, sir.
Sorry, please come again. Current. Okay, current will go high. Okay, so the power requirement will suddenly become high. Yeah, right. Okay. Any other problems? Because of that, what will happen? Yeah. GB is gearbox. So Hassan, GB is gearbox. Yeah. Okay. Can someone tell me? Suddenly, you are the facility manager. Just imagine, like you are the substation manager or the facility manager. Suddenly, they are saying, like, I'm going to give you 5 more furnace. What will happen? Or what will be the challenge as a facility manager or an electrical engineer of that particular plant?
We need to increase the transmission power.
We need to increase the transmission power. Okay,
Yeah.
good. Yeah, good answer. Great. Yeah. Anything else? What? Okay. Yeah. Anything more than this? Yeah. Can you add equipment suddenly to a plant? What are the legal requirements or what are all the technical requirements you have to take into consideration? Can you do that? Just a hint. Yeah.
Sanctioned MD to be raised, sir.
Yeah. Yes, Silamohan sir. Perfect. So the first and the foremost thing is the maximum demand. Okay. I don't know about Bangladesh, but in India we follow something called 2-tariff system. Okay. 2-tariff system. That means I pay for the maximum demand, okay, which is in kVA or MVA. Okay, it will get calculated, and I also pay for my kWh. Okay, that is my energy consumption. Obviously, there are power factor and other penalties are there, but basically I have 2 charges. Okay, so this will be fixed. Okay, and this will be based on my consumption. Based on consumption.
Sir, one Muhammad Rafi have told that design point of view check the line capacities.
Yeah, perfect, Ravi, Rafi. Yeah, you're right. You're right. Yes. So the first and foremost is this maximum demand is one problem. Second problem, as Rafi have told, the design capacity. Design capacity. Okay. Anything else would be a problem? Yeah, 2-part tariff. Yes. Yeah. Okay. So I think this is something I would say you can do it, provided you do the second one. Yeah, one you can do it, but you have to finish the second one. Design capacity is very, very important rather than going for a maximum demand rise. Maximum demand rise, if you ask, they will give you, not a problem, provided you have to prove that for that you have the load and you have the transmissions and other things for that. Yeah, that is the very important thing. So now design capacity, as you rightly said, that this is the important factor here. The factor or the problem what the people face there, or I faced rather there, is the distribution. The distribution is I have yeah, 33 kV grid. Okay, actually the incoming is 220 kV. After that I have a step down. Okay, and then this line comes, which is 33 kV. Yeah. And after this 33 kV, I have transformers, okay? And this transformers is 33 kV, 415 volt, okay? And this is going to say, okay, 4 furnaces already, yeah? And suddenly, I have similarly, say, 3 furnaces there, okay? Everything is 33 kV, 415 volt, 33 kV, 415 volt. And this was scattering for some furnaces. Again, this was scattering for some furnaces. Okay, again, I will have some breakers here. Yeah, so this is how it is, and there is also some type breakers here. Yeah, so this is how my single line diagram would look like. Okay, so what happened is I don't have a spare capacity. What I can do is, obviously I can extend it. I can connect one more new furnace here, right? I can add one more. I can add maybe 2 more. I can add maybe 2 more. Okay. So what happens is 1, 2, 3, 4, 5. I can add it, right? So 4 furnaces I can add. And each is of how much? 600 kilowatt into 5, which is almost like 3000 kilowatt. Yeah. So this is the capacity. As it is resistive, you can also say like, okay, 3000 kVA, because it is a pure resistive load, or I would say majority is resistive load. The another problem what I have is the sizing of this transformer. Already this sizing of the transformer is, this is 2 MVA, this is also 2 MVA, okay, and this was somewhere around 1.8 MVA. Okay, so it was catering to some loads already, and it is being designed and it is being approved by the people. Okay, and there is one more aspect, the 1, 2, and there is a very important third aspect, and I will mark it in red, which is design capacity approval. Okay, by chief inspector to government, chief electrical inspector to government. Yeah, CEIG. Chief Electrical Inspector to Government. In India, we have that, and I hope in Bangladesh also you will be having it. Yeah. So there is a government approval also we need, who will validate how the design is done and whether it is safe. Okay. So that is something which is very much audible. Yeah. I think, sir, Jagdishan, sir, maybe you can increase your thing. Yeah. Yeah. I will try to increase my volume also, not a problem. Yeah, great. So this is the problem what they faced. Okay, and now there is a solution needed. So now you have a real problem. Can you suggest how you can use IoT and give us a solution for this? Can anyone unmute and give your thoughts, or you can also text it? Yeah, how you can give a solution using IoT here? Yeah, I hope you saw this. Okay, you know what is the problem. I will show you the technical, I would say, block diagram or general arrangement. Okay, it has a PLC and there are thyristor controls. Yeah, and this is how it is. Yeah, can someone suggest me what the team should do? And here they have used IoT, and how using IoT we can find a solution. What is this? No one is speaking. Come on, IEEE members, come on. It's a very simple question. Any answers? Come on. No answer is right or wrong. Kindly unmute and speak. Okay, so no one is ready to talk, no problem. Fine. So what we did is something called, it is called demand. Yeah. Yeah, please. Any thoughts through the IoT using, we can know the load demand. Yeah, we can know the load demand. Yes, Hassan, but how we can go to the next level? We have to do something like demand side management, right? Here, it's a management of the demand. Okay, if you are able to manage the demand, obviously you will be able to have a better grid. Shifting of loads? No, but shifting of loads using IoT. We are talking about IoT, right? Shifting of loads is a classical, say, restructuring of your electrical infrastructure or electrical grid, right? Using IoT. Okay, so like you guys, I also got struck. Okay, and I think those are the days when I was talking to a lot of people, and I got some good academic friends who suggested how this can be done, and we identified some party also who can do it. Unfortunately, those technologies, those time are available at Germany, and we imported the technology and we used it. Yeah. So that's something what we did, and this is what I'm going to explain to you all. Yeah. So I told you that in this you have something like called a PLC. So what is a PLC? Anyone know what is a PLC? This one. What is a PLC? Full form of a PLC?
Programmable logic controller.
Okay, great. Yeah, good. So do you think like that is an intelligent device? You can make it intelligent? Very good. Yeah, great. Yeah, that is what we did. Yeah. So Wahid Zaman, yeah, your answer is perfectly right. That is what we did. Yeah, we triggered the thyristor, okay, and using an algorithm, we calculated how much would be the load or the maximum permissible load of these transformers, and we triggered the thyristors, okay, such a way that the demand is smoothened. Yeah, that is what we did in this particular case. Yeah, cool. So, just to save some time, probably I can give you the link of my ResearchGate article where you can find more information about this, yeah, and you can use that for your further research. Yeah. Just a minute. Okay. So if after this you can go through that whenever time permits, and probably you can ping me if you have some doubts and other things. And now we can go to the next topic, which is blockchain. Yeah. Go to the next topic, which is blockchain. Before that, I will just post my articles link in the chat, and you can go through it when okay. There you will have these things. Okay. Visible for you. Okay, this is the link of my thing, and you can go through it when time permits. Let me rush through so that you know what it is. Yeah. So this is one of the presentations I have made some time back. Okay. And I will directly go through the things. Yeah. You can see what we did is we want to avoid these peak loads. What we want is we want to avoid these peak loads and we want to smoothen the demand. Okay. And what we did is this is all the furnaces are switching on at their mercy, or I would say at their will. Okay, so that is the problem what they were facing, and what we try to do is we try to minimize it using a switching algorithm so that the thyristor switches in a sequence such a way the optimum peak load is there. Okay, so something from here, from this particular point, it is being now. Yeah. So somewhere from here, it is being now minimized to something here. Okay, this is the savings. So how we did is first, it is not simply you cannot switch it. You have to understand the process. So we deployed. I always tell to my students, like, you always use this particular terminology, USA. Okay, understand the process, simplify, and after that automate. So when we understood the process, we see that there is a scope for the first 60 minutes to optimize, and after that, the last 20-30 minutes also you can optimize. That means you can do a demand control. It's if you switch off for a fraction of say minute during that particular period of recovery and drop, nothing is going to do in the happen in the process. Okay, so that is what we try to do it. Yeah. And how we implemented, I will just go to that particular slide. You can see from the PLC, there is a signal coming to the thyristor. It is in the form of 0 to 10 volt. And in between, we inserted an embedded system, okay, and this acts as an in between between the thyristor and the PLC. Okay, so we inserted an hardware, and this hardware gets communicated to the upper level systems, and the upper level system will keep a track of what is the load of each and every transformer, and there is a small algorithm which will always see like whether the transformer load is less than 1.27 MVA, which is the ideal load of that particular transformer, and it will see like, okay, what is 100% is this furnace is asking me energy. That means in terms of 10 volt is 100%, 5 volt means 50%. And what it does is it does a quick calculation and see whether there will be an overload of the transformer. If there is no overload, it will allow the reference to come to the thyristor. And when it is an overload, what it will do is, even if the furnace PLC asks 10 volt, it will not give you the 100%. It will only give you 8 or 80%. Such a way, the limit is adhered. Okay, the limit, by the way, here is 1.3 MVA for this particular transformer of, I think, 2 MVA. Okay, so that is the safe load. Okay, in order to avoid some overshoots and other things. So we used for a pilot. Okay, so things cannot happen over the night, right? So pilot, we use LabVIEW kind of systems to implement it, and we drive this project. After that, we went to German supplier, and with them we were able to implement it. Okay, it's cool. So this is about IoT implementation. Hope you got some, I would say, basic information of how this can be used in an industry. Yeah, and industry, you will have these kind of problems then and there, and you have to solve those problems. Yeah, so that's what is expected from an electrical engineer there. Yeah. So with this, let's go to the next mentee. The mentee here is about blockchain. So what I want to understand from each and every one of you is, have you seen how a blockchain works? Yeah. So let me understand from you, and after that, let's calibrate our review course based on what you guys say or what you participants say. Okay, so this is the next mentee. can click and cast your votes. The question is, have you seen how blockchain works? It's a very simple yes or no. So it's very simple to vote. Okay. There are yes, there are no's. Okay. Okay, we are 73. At least we should touch some 40. There are only 18 participants who have given their view. 19 now. Can I have more, please? Okay, 20. Come on, what happened to other participants? At least we should touch 40. Okay, so there is a very clear difference between yes and no. There are few who have seen it, and the majority of others have not seen it. So with that, I want to first introduce you the blockchain. Okay, for this, I strongly recommend in all my sessions Mr. Andre's website. I don't know how many of you have seen it. I have just put the thing there. Okay, first of all, blockchain, why it is needed, what it is first of all. Okay, so this is based on something called hashing. Okay, so what is a hash? It is something like a unique number or a unique key which gets generated with a computer algorithm. Okay, and the hash normally it is something like 256. You see, this is the bits. Okay, how many bits this particular hash would be. For example, I put my name Somo. Okay, for Somo the hash is this. Yeah, you can see this is the hash for Somo. Okay, I delete this and again I put Somo. You can see the same hash. Can you see 34D06? In the last, you just track it. Okay, and I delete it and I put the same. You can see again and again I am getting the same hash for my characters. This is nothing but it's something an encoding technique. Okay, which computers use. Okay, let's not go much deep into it. Now this hash is the basics for blockchain. And now let's understand what is a block. Okay, so block is nothing but it has a serial. Okay, and it has something like nonce. Okay, you don't have to see what is what. Okay, but just understand what it is. Okay, so these are all the identifiers for each and every block. Say a block number 1, and I am putting Somu here. You can see there is a different hash which is getting generated. Now, when I modify this, what happens? The total block is going red, right? So what it also does is, once I change it, I have to sign it. So in this particular environment in the UI, they have given something called mine. Mine is nothing but signing it, okay? So what I will do is, I will first enter the data, what I have to send, and after that, I will put mine, okay? Then what will happen? It is becoming green, you can see. So now what happens is there is a signature I am making for my data. So I have my data, I have something called nonce, I have the block ID, and I have some unique number which is hash. Okay, and this gets created, and I have mine. So this is my one block. Okay, now what is a blockchain? So this is one block, right? What is a blockchain? You go to blockchain here. Here very superbly and Andresa have put it. Okay, for example, here I say like it is Somo, and I mine it. Okay, it will go green. After that, I'm going to block 2. Okay, saying I'm Somo. My second name is Bala. Okay, so Bala Subramaniam Somu Sundaram. So that is my name. Okay, then I say mine. Okay, again it will connect my previous hash, okay, previous hash here, and my present hash. So this also will be treated as a data. My previous hash will also be treated as a data. Now, what I'm doing is, I want to do a name change. Okay, so what I'm doing is instead of a SOMO, okay, let me do this also. Okay, I say like I stay at Coimbatore. Okay, and I mine it. Okay, similarly, I can put all these information, so no problem. Okay, just imagine I'm going to change this SOMO. No, it's not SOMO, it is Somu Sundaram. Okay, just imagine when I touch this and I change something, everything is getting changed. Okay, so this is the chain. Okay, I cannot change one block at any time. Okay, if I have to change it, then I have to change all the blocks. Okay, so this is how blockchain works. If I have to change again, I have to sign it. Okay, it will have some timestamp and other things. Only then it will get green. Then I have to change the next one, and then I have to change the next one. Suddenly, I say like, hey, I want to change this. Okay, it's not Bala, it's Bala Subramanian. Okay, can you see? If I change it, what happens? This is unchanged, but from this onwards, all my blocks will go red. Okay, I will not be able to do any small change only in this particular area. Okay, so this is what blockchain. Again, if I have to normalize it, I have to sign it, and I have to sign all other blocks. Just imagine all other blocks. If I made 1,000 blocks after that, and I want to replace one of the block, some 1,000 blocks before, then I have to sign all the 1,000 blocks. Now, let's see what is it. Distributed computing. Distributed computing is nothing but instead of having this blockchain in one server, you have it in all the servers. For example, here I say that Bala, okay, and Somo and Coimbatore. Yeah, Coimbatore. Now I also put in peer B, that is my another computer, okay, another server, okay, which I may have it in Bangladesh also. This I am having in India, okay. So I put it, okay, and I can mine it, okay. Mine. That mine is nothing but signing it. Just have an analogy, something like that, okay. Now I have mined it, and I'm going to mine this also, okay. Suddenly, what happens is in India server, okay, I have an influence in India, okay, I know all the people, okay. I say like in India, I'm going to change this particular number, okay. Instead of Somo, it is a Soma, okay. And what I do is I somehow manage to sign this also, okay. Now what happens? I can do the change here, but I cannot do the change in PRB, right? So the server in Bangladesh will have a different data, whereas I will have a different data. Then after this, what will happen is in the distributed ledger, there will be one more server. There will be one more server, okay, which will be there in the top, which will supervise whether all the peers are having the same data or not. If it is not having the same data, then it will say like, hey boss, I think the server 1 is having a different data and server 2 is having a different data. So this is about blockchain. Okay, any questions here? Any questions?
Sir, in what way blockchain is connected to the power system now, sir?
Yeah.
If you could able to connect it, it will be useful for everyone.
Yeah, very nice. So I think again, it's not individuals' information. Let's go to the collective responsibility. Okay, so that is my next mentee. Okay, what do you think about blockchain application in smart power system and where it is used and why it is used? What you all think about it? Okay, so this is the next mentee. What I want all of you to answer it. Let's find out from you all. Okay, so you all, then my life is easy, and I think you all also can learn from each other. Yeah. So this is our next mentee. I have put the link also in the chat. So what comes to your mind? How this can be used? Yeah. Can I have some responses, please? How blockchain can be used? Consumption. Okay. A system who maintains states. No, I'm asking how blockchain can be used in a power system. It's data storage and processing. Okay. So very important. Blockchain is very costly. Entity built into a peer-to-peer network. I don't know. Vending of smart prepaid meter. No, see, why then? Okay, great, I accept. Okay, vending of smart prepaid meter. Okay, but why it is used? Track the production of clean energy. Again, yeah, where it is used, great, you have answered. Why it is used? You have answered. Track the production of clean energy. Yeah, perfect. But why it is used? No. Yeah, sorry, blockchain is a specific type of database. No. That is not the answer what we are looking at. You have put where it is used, but why? As we know, security of the data in the power system is very crucial. With blockchain, we can transfer data without concern of wrong data or data integrity. That means someone have changed the data. Energy trading, great. Energy trading, it can be used, yes. Identify the error when it is occurring, great. Yeah. Anything else? Lot of places it can be used. Yeah, it can be used in, yeah, blockchain can be used for smart grid. Yeah, then why? Okay, smart grid, agreed. Why? Microgrid monitoring and control, great. Then again, why? I think this is the, I would say, a perfect answer. Okay, security of the data is very, very important. Okay, and that is the reason blockchain is being used in energy. Okay, because the important factor is we are speaking about energy trading. Okay, and energy trading, when you have to do, okay, there are 4 people, distributed generation is happening, and one person is saying like, no, I have done this generation. Okay, but the other guy will say like, no, you haven't generated that much. In my meter, it is showing something like this. So if you have a blockchain and you connect all your meters and your metering system as peers, what will happen? The data from one computer will be available in other computer as a copy, and at the same time, you will have more trust and integrity of the data is assured, okay, or ensured. Obviously, people are arguing like with the coming of quantum computers, you can also hack a blockchain system. Obviously, that is a topic for future. But as of now, the present state, this is the best way how you can secure transactional data. Okay, and nowadays I think people are using it for storing, say, government records and other things. Already people are using it. Supply chain is using it. Yeah, blockchain and blockchain technology is the game changer for energy supplies. Yeah, great. Yeah, anti-counterfeiting, but here it is more with energy. And another use case, what I want to bring to you is the settings of the relays. Okay, there also people are using hashing technology. Okay, the one of the very simple thing is the CRC. Okay, in all of our programs and other things, you will have this checksum and all those things, right? The unique number gets generated. Okay, the same way now people are moving towards the hashing algorithms where they are ensuring like the source code or the firmware of each and every relay is secured, or what it is available at the say the source end. That means the OEM is the same what is working in the say the power grid or Bangladesh power grid or India power grid. Because nowadays what happens is social engineering and other things are also coming into play when cyber security is being discussed. Even people are cloning a device and they are putting a bug inside the firmware and they are sending it. What will happen? You put it in your central power grid, then that becomes an IED, and that intelligent electronic device, if it is having a malware implanted firmware, then it will start erratically behaving, or it can start giving access to other people to operate your grid. Okay, so that is the application of a blockchain, and you have seen how a blockchain works and how this can be used. One is for energy accounting and another is for the security of our devices. Even people are researching that if there is a trip or yeah, I'm not talking about trip. Okay, let's talk about say a command. Okay, from a central command center, you are giving a command, and that command, if it is coming from the central command center or from a hacker, who knows, right? So for that also now people are using technologies like if you give a command from one substation, the same command have to be also peer networked to your other systems, and if it is matching, if both the things are matching, only then the command will work for a remotely operated substation somewhere else in a desert or in some areas. Okay, in order to avoid hacking. Okay, those kind of things are coming. But tripping, it will immediately trip. Okay, but the tripping circuits, how secure it will be. It will not be normally connected to any network. Okay, but the normal activities or a SCADA activities, then obviously there will be a remote trip possibility or a remote command. I will not term it as trip. It is a remote command possible. The remote command, now people are exploring how blockchain can be used so that they can ensure that it is secure and an authorized trip. It is not someone like a hacker who have created that particular trip. Okay, and I think there are a lot of examples of people hacking systems. Recently, Maharashtra government declared like there was a cyber attack. A lot of things are there. Okay, so with this, let's go to our last mentee. Okay, where I want to have your feedback, so how it was, okay, and how this can be improved. Or I think, Ilangovan sir, you will have a feedback session, right, sir? Yeah. So maybe I will collect the feedback from you. Not a problem. Yeah.
Yes, sir. Yes, sir. Feedback will be collected in the registration
Kindly
form.
share with me, sir, so that I can improve also. Yeah.
Sure, sir. Sure, sir.
Okay. Thank you all for active listening. And I think we have now touched 49 entries, right? Very good. It's almost 50% of the people have participated. Good.
Yes, sir. Thank you so much, Somasundaram, sir. Over to the MOC team. Probably they'll be having a formal vote of thanks.
Yes, sir. Thank you. Thank you, Dr. Somasundaram, sir. We really appreciate the time you took for sharing with us your knowledge about applications of IoT and blockchain. As the world is becoming more and more dependent on these two, this webinar has made it easier for all of us to begin our journey in these fields. I would also like to thank the respected principals of both Jansen's Institute of Technology and Bangladesh University of Business and Technology for being our backbone throughout this process. This webinar wouldn't have been possible without the constant effort and support from our student branch counselors and women in engineering advisors, so hereby I extend my gratitude towards them too. Last but not the least, this session got its life from all the participants and the volunteers. This wouldn't have been a success without you all. So once again, I thank each and every one who were present here for giving your support and cooperation and for making it happen successfully. Thank you all. Take care. Be safe.
Thank you, Shruti. Now I'd like to call upon MD Aslamuddin, Professor at BUBT, to share some words. Sir?
Thank you, sir, for your valuable speech regarding the seminar. It was really helpful. I think everyone will learn a lot from it. And it has been a pleasure being with all of you today, and thank you for all your patience. I wish you all a very good afternoon. Stay safe and stay well. And this is the ending moment of today's event. Thank you.
Participants, kindly share your feedback through the feedback link which is posted in the chat box.
Thank you all. Thank you so much.
Thank you all. And e-certificates will be provided to the participants who fill the feedback form. Thank you.